Children, today I'm going to talk about some questions from exercise 7.5, which is based on increasing and decreasing function there. Now the function given to me is fx equals to ax plus b, where a and b both are constants, and the condition is that a should be less than 0 for it to be a decreasing function. Now, here I am assuming that let x1 and x2 belonging to R be such that x1 is greater than x2. So therefore this implies that ax1 will be less than ax2 for some value of a which is greater than 0. So therefore when I say that for some a being greater than 0 and ax1 being less than ax2, I am adding b to both the sides, and I know to my statement if I add the same quantity the resultant remains the same. So therefore ax1 plus b will also be less than ax2 plus b for some value of b, which implies my f of x1 will be less than f of x2. That means I've come to the conclusion that for every x1 being greater than x2 implies f of x1 is less than f of x2, which means my fx has been proved to be a decreasing function of R over here. The next question which I am taking up is, which says, show that f of x given to you as 2x minus sine 2x is increasing for all x belonging to R. So therefore now let's see. First rule is my fx is given to me as 2x minus sine 2x, so I differentiate. I get f dash x equals to 2 minus 2 cos 2x. Now it's given to me that for every x belonging to R, minus 1 less than cos 2x less than 1. So therefore, multiplying by minus 1, the symbol of inequality gets reciprocated. So it becomes now 2 being greater than minus 2 cos 2x greater than minus 2 now. Now further, I am going to now add 2 to it. So I will get 4, that is 2 plus 2 being greater than 2 minus 2 cos 2x being greater than, the other side would be 2 minus 2, that is 0. So my inequality is completely now 4 greater than 2 minus 2 cos 2x greater than 0, which now shows that f dash x is greater than 0. And this is the condition for any function to be increasing if it is f dash x is greater than 0. So now I've noticed over here that fx is increasing on the interval of x belonging to R. The next question now I have picked up is 13th question, third part, which says now this time fx equals to cos square x is a decreasing function on the interval now 0 to pi by 2. So the function given to me is cos square x. First step, I differentiate and I get the answer as 2 cos x times minus sin x, which can be simplified and written as minus 2 sin x cos x, which is further giving me as minus sin 2x. Now it's been told to us in the question that x belongs to 0 to pi by 2. If x belongs to 0 to pi by 2, that means 2x belongs to the interval 0 to pi, which implies now sin 2x will be greater than 0 because it is the interval of 0 to pi, which means when I multiply by minus 1, I get minus sin 2x being less than 0. The symbol of inequality gets reciprocated. So therefore now I get f dash x being less than 0, and this is the condition for any function to be decreasing. So therefore my fx, which was given to me as cos square x, is a decreasing function on the interval 0 to pi by 2. So every time I'm trying to satisfy the condition of f dash x being either greater than 0 or less than 0. If it is less than 0, it's decreasing. If it is greater than 0, it is increasing. Now the next question which I'm taking up is, function x has been given to you cos x, and there are three cases which you have to study over here. First one is saying strictly increasing in the interval pi to 2 pi. Second says decreasing in the interval 0 to pi. And the third one says it's neither increasing nor decreasing between 0 to 2 pi. So the function given to me is fx, which is cos x, which implies f dash x is equal to minus sin x. This differentiation is going to be used in all the three parts there. Now let's see the first one. First interval says let x belongs to pi to 2 pi. If I say x belongs to pi to 2 pi, that means sin x is going to be less than 0. If sin x is less than 0, that implies minus sin x is going to be greater than 0. Further, which means f dash x is greater than 0. That means my fx over here is increasing in the interval from pi to 2 pi. Now let's take the second one. It says 0 to pi now. Now this time let x belong to 0 to pi. Now if x belongs to 0 to pi, it means sin x is going to be greater than 0. If sin x is greater than 0, it means minus sin x is going to be less than 0, which further means f dash x is going to be less than 0. And now I know that this is the condition for decreasing function. So therefore it has been proved over here that fx is decreasing in the interval 0 to pi. Now let's see the next part where it says neither increasing nor decreasing in 0 to 2 pi. Now I have observed over here from the first two parts that fx is decreasing in 0 to pi but increasing in pi to 2 pi. That means if I have to talk about 0 to 2 pi, I will say it is neither increasing nor decreasing in 0 to 2 pi. You cannot say just one thing for the complete interval 0 to 2 pi. The third part says that. Next question now. It talks about x square minus x plus 1 is neither increasing nor decreasing in the interval minus 1 comma 1. Now the function given to me is x square minus x plus 1. When I differentiate, I get f dash x as 2x minus 1, and if I put it equal to 0, I'll get the value of x as half. So half would be a value over here of the domain to be studied with reference to. Now I'm going to take the first breakup now. That is, let x belong to minus 1 to half, because my interval is given to me minus 1 to 1. So I am breaking it into parts and I'm going to study it as minus 1 to half in the first case. When I do that, in the interval of minus 1 to half, I observe 2x minus 1 will be less than 0. That means f dash x is less than 0. If it is less than 0, it means fx is decreasing in the interval from minus 1 to half. Now similarly, let's take the other side of it. Let x belong to, this time, half to 1. When I say let x belong to half to 1, this time now 2x minus 1 will be greater than 0, which implies f dash x is going to be greater than 0. Now the condition for increasing has been satisfied. So therefore fx is increasing in the interval this time now half to 1. Now from the above two conditions, I have observed again that in the first part it was decreasing and in the second part it was increasing. So therefore, it satisfies the condition that it is neither increasing nor decreasing in the interval from -1 to 1.